So let's look at some examples of solving second order differential equations. So take the first example here, d squared x by dt squared plus 36x equals 0. The initial conditions at t equals 0, x equals minus 1, dx by dt equals 2. So we can write that in shorthand as x double dot plus 36x equals 0. We can then take the Laplace transform of it, and for this first section here, the second differential, will give us s squared x bar minus sx0 minus x1, and the 36 is replaced by 36 x bar, and that all equals 0. So then multiplying out the brackets and also putting in the initial conditions. So the initial conditions here, x at t equals 0, x equals minus 1, so that's telling us that x0 is equal to 0, so that term disappears, and dx by dt equals 2, so that means that value there, x1, becomes 2. So we have our s squared x bar plus s minus 2 plus 36x bar equals 0. So we take out the common factor of our x bar here, we'll have left with s squared plus 36 x bar plus s minus 2 equals 0. We can then transpose that for x bar, which will equal 2 minus s all upon s squared plus 36. So we can split these into their component parts, 2 upon s squared plus 36 minus s upon s squared plus 36, and when we do the inverse transform of that, we'll get 1 upon 3 sin 6t minus cos 6t. Number 2. d squared x by dt squared minus 6 dx by dt plus 8x equals e to the 3t. The initial conditions at t equals 0 are x equals 0, dx by dt equals 2. Again, we can write that in shorthand form. That's going to be x double dot minus 6x dot plus 8x equals e to the 3t. We then take the Laplace transform of this equation here, giving us our s squared x bar minus sx0 minus x1 minus 6 times sx bar minus x0 plus 8x bar equals, in the Laplace transform of e to the 3t is 1 upon s minus 3. We then put in the initial conditions for x0 and x1, so x0 is 0 and x1 is going to be 2. So that gives us our s squared x bar minus 0 minus 2 minus 6 times sx bar minus 0 plus 8x bar equals 1 upon s minus 3. So we gather like terms, and x bar will give us s squared minus 6s plus 8, x bar equals 2 plus 1 upon s minus 3. We can then take this term here over to the other side and have a common factor there of s minus 3 for these two, and it will give us our 2 s minus 3 plus 1 all upon s minus 3 times s squared minus 6x plus 8. We can then factor this one out into s minus 2, s minus 4. So this whole thing here can be written in terms of a upon s minus 3 plus b upon s minus 2 plus c upon s minus 4. We then use the cover-up rule in order to work out the values for a, b and c. So I won't read through these, you can see them for yourself and read through and check and see the validity of them. So this will give us our value x bar equals minus 1 upon s minus 3 minus 1 upon 2 s minus 2 plus 3 upon 2 s minus 4. And when we go through the inverse transform of that, it will give us minus e to the 3t minus a half e to the 2t plus 3 upon 2 e to the 4t. Number 3. d squared x by dt squared plus x equals 6 cos 2t. The initial conditions t equals 0, x equals 3, dx by dt equals 1. This can be written as x double dot plus x equals 6 cos 2x. Taking the Laplace transform of this gives us our s squared x bar minus sx0 minus x1 plus x bar equals the Laplace transform of 6 cos 2t is equal to 6s upon s squared plus 4. Now, we can go ahead here and we can put in our initial conditions when t equals 0, x 0 equals 3 and x1 equals 1. This is going to give us our s squared x bar minus 3s minus 1 plus x bar equals 6s upon s squared plus 4. Okay, now we can take out our common factor here of x bar, gives us this term here, and then we can take the s squared plus 1 down, and it's going to give us this term here. So we can take out the common factor here on this of 6s from this term here, and it will leave us 1 upon s squared plus 1 s squared plus 4. So this thing here can be written as a upon s squared plus 1 plus b upon s squared plus 4. So multiplying throughout, we'll have our as squared plus 4 plus bs squared plus 1 equals 1. We can then start taking coefficients. So the coefficients there of s squared is a plus b equals 0. The coefficients of the constant term is 4a plus b equals 1. So we can work through the derivation here. I'll leave you to follow through the derivation yourself. And it's going to give us the value of b equaling minus 1 upon 3 and a equaling 1 upon 3. So just read through that, it's just a simultaneous equations. So this means the term here can be written as 6s 1 upon 3s squared plus 1 minus 1 upon 3s squared plus 4. So taking out the 1 upon 3 gives us our 2s 1 upon s squared plus 1 minus 1 upon s squared plus 4. Now putting all the terms in together, we'll have 2s upon s squared plus 1 minus 2s upon s squared plus 4 from above, and then from the initial one we worked out from the top of the problem, we're going to be left with our 3s upon s squared plus 1 plus 1 upon s squared plus 1. Adding the like terms together, we're going to be left with 5s upon s squared plus 1 plus 1 upon s squared plus 1 minus 2s upon s squared plus 4. Taking the inverse transform of this gives us 5 cos t plus sin t minus 2 cos 2t. Number 4. t squared x by dt squared plus 3 dx by dt plus 2x equals 4t squared. Initial condition t equals 0, x equals 0, dx by dt equals 0. We can write it down in this simple form here. X double dot plus 3x dot plus 2x equals 4t squared. Taking the Laplace transform of this equation here gives us this equation here. I won't read it out, it's the same as in the previous ones. Laplace transform of 4t squared is 8 upon s cubed. We then gather like terms, so we've gathered the like terms here, and we take this term over to the other side, gives us our x bar equals 8 upon s cubed times s plus 1 s plus 2. So we can take out the common factor here of our 1 upon s squared, leaves us at 8 upon s plus 1 s plus 2. This can then be written as the a upon s plus b upon s plus 1 plus c upon s plus 2 using our partial fractions, and that is going to be equal to our a upon s plus 1 s plus 2. We can then use the cover up rule in order to find our values of our a, b and c. So I've done that down here. Again, you can read through that yourself to give the value of a equals 4, b equals minus 8 and c equals 4. So finally we can put it all together as 1 upon s squared times 4 upon s minus 8 upon s plus 1 plus 4 upon s plus 2. So that is equal to 4 upon s cubed minus 1 upon s all times 8 upon s times s plus 1 minus 4 upon s times s plus 2. That can be written as 4 upon s cubed. We can take out the common factor here of our 1 upon s. We've already taken out the common factor of 1 upon s, and we'll be left with our, now these will get split up into 8 upon s minus 8 upon s plus 1, and this one here is going to give us 2 upon s minus 2 upon s plus 2 upon s plus 2. So you can check that these two add together to get this here. So that's going to give us 4 upon s cubed minus 6 upon s squared plus 8 upon s plus 1 minus 2 upon s plus 2. Finally we'll be left with this equation here, which simplifies to this one here, and when we find the inverse Laplace transform we'll get x equals 2t squared minus 6t plus 7 plus e to the minus 2t minus 8e to the minus t. Now number 5. d squared x by dt squared minus 2 dx by dt plus 5x equals e to the 2t. Initial conditions t equals 0 when x equals 0 and dx by dt equals 1. It can be written in a simpler form: x double dot minus 2x dot plus 5x equals e to the 2t. We then do the Laplace transform of this here as usual, and it will give us this line here. Again we then put in the initial conditions. The x0 becomes our 0 and the x1 becomes our 1. We then gather the like terms in x bar and then transpose for x bar, giving us 1 upon s squared minus 2s plus 5 plus 1 upon s squared s minus 2 times s squared minus 2s plus 5. Taking the first term here and completing the square on it gives us 1 upon s minus 1 all squared plus 4. Taking the second term here using partial fraction expansions gives us a upon s minus 2 plus bs plus c all upon s squared minus 2s plus 5. We can then multiply throughout by the denominator here, as I've done here, and we can take coefficients of s squared, coefficients of s and coefficients of the constant, and I'll leave you to work through those yourself. So when you work through them, you're going to be left with the values of c equals 0, or a equals 1.5 and b equals minus 1.5. We put these back into the initial equation. It gives us 1.5 times 1 upon s minus 2 minus 1.5 times s upon s squared minus 2s plus 5. So finally our x bar is going to give us this term here. We'll leave the first term as is, the second term as it is at the moment, and the third term we'll rewrite it in this form here, so we'll just split it up. If you multiply these back together you'll see you'll get that top line there. Again, leave the first term, the second term, and then multiply out the brackets here with the 1/5, and then gather up the like terms, and it'll give us our three equations here. And we take the inverse, three equations here, and we take the inverse Laplace transform of these. It'll give us x equals 2.5 e to the t sine 2t plus 1.5 e to the 2t minus 1.5 e to the t cos 2t.